Well, thank you, Bill. It's, of course, a great pleasure to be back in Seattle and see so many of you. And actually, you haven't changed much. And Bill Gates have to expand this auditorium if this is going to continue. We look forward to that. So if we can get the first slide. This is the primary outcome of the TEDdy study. We want to learn what the environmental factors are which are inducing those islet autoantibodies that Bill talked about. You know, why are they there? What made them to appear in the child? Because they are not going away. So in most of our children, they become permanently islet autoantibody positive. And as Bill showed, if you have 2 or 3, that is diabetes, even if you don't have any diabetes symptoms. That's what we have learned from TEDdy. Islet autoantibodies were much earlier than we expected. And you will see it in this slide. So it's complicated. The slide up, so Bill showed 4 risk genotypes. These are the 4. And in the upper left corner, the red line is the insulin autoantibodies. The blue line is the GAD autoantibodies. And it's showing the first autoantibody that the child got. So you can see in the upper left corner that if you have that genotype, HLA-DR3/4, the autoantibodies against insulin came already during the first year of life. We did not expect this early start of a disease that normally is diagnosed when the child is a teenager. Okay? The blue line in the right lower corner is the HLA-DR3/3 children. And that's the GAD autoantibodies. And you can see that when you're 3/3, it's predominantly GAD autoantibodies that the children have, not insulin. So the genetic risk for developing the islet autoantibodies, that's HLA. It's not diabetes. It's the risk of getting these autoantibodies. So these are the results that we have so far in TEDdy. The youngest TEDdy child is now 4.5. The oldest is going to be 10 this year. 4.5 to 10, that's the whole group. And as you can see, we have in the beginning 8,502 children, and 6% or 5.9% of the children have so far got one first autoantibody. And some of them have, of course, gone on, as I will show you, to get a second autoantibody and a third, and then develop diabetes. So insulin autoantibody only as the first autoantibody was in 225 children, and that's 45% of the group. These are numbers that will not change. These are final TEDdy results because these events of the autoantibodies happened before 4 years of age. GAD only is 172 children, 37%, and then you have a smaller group of 15% who did not have one autoantibody. They had 2 as the first autoantibody. And then IA2, the third islet autoantibody, is rare, as you can see. Only 17 children had that as the first autoantibody. So you say 6%, what about the others? Well, those are the TEDdy control children. They have the same genetic risk. They live in different countries. They are exposed to different environmental factors, and they did not develop an islet autoantibody before 5 years of age. So TEDdy has many control children, and you will see the importance of that. Now, what risk factors were there for the TEDdy children to develop their first islet autoantibody. So IAA, the insulin autoantibody, the red curve, is boys, higher risk, born in the spring or in the fall, higher risk, and if you had light therapy, jaundice at the time of birth, reduced risk. GAD autoantibody only, you remember the blue line, different genetic risk. Increased birth weight increase is higher risk. And jaundice and light therapy is higher risk. So it really illustrates how different, there are two different diseases going on in these children. So different triggers for IAA and GAD are likely, and the genetic risk. The HLA is what's controlling, not diabetes, it's controlling if you get these islet autoantibodies in response to something. Good news for the future. Children who were given probiotics before 3 months of age were protected from islet autoantibodies. You know, lactobacilli, etc. It's a very strong results that we believe in. Okay, so we have risk factors, but we also have protective means. And once this is clarified, I think this is important for public health to inform the public that this is a way that maybe you can reduce the risk of type 1 diabetes, because you don't get type 1 diabetes without the islet autoantibodies. Next question. What has happened to the child at the TEDdy visit prior to the visit where we found the first islet autoantibody? Isn't that the key question? Wouldn't that be what you were asking? A child who had the first islet autoantibody at 18 months, negative at 15, negative at 12. We want to know the visit before the islet autoantibody, is that going to tell us something? And it did. Febrile respiratory infections in the preceding 3 months was a predictor of islet autoimmunity, predicted if the child developed an autoantibody or not. Okay? So obviously Sherlock Holmes of TEDdy is not looking at the visit when the antibodies were there the first time. Sherlock Holmes of TEDdy is looking at 15 months. So how do we find the trigger of islet autoantibodies? Either insulin autoantibody only, GAD only, or both of them. That's were the 3 major types. We collected a lot of samples for scientists to use. This is unbelievable. We have 865,000 plus plasma samples from the TEDdy children in the 4 different countries. We have stool samples. I mean, the 573,000 stool samples. I mean, think about all the shit in this. And we, serum, I can't go on. But I think you understand. Lots of -80 freezers in Morgantown in Maryland. So what TEDdy does is nested case control studies. So we have already started with the analysis. We have 419 children in the first round of finding out the trigger. And depending on the cost of the analysis, we do either 1-to-3 matching or 1-to-1 matching. And you can see we do dietary biomarkers, metabolomics. We look at all the metabolites that are out in the plasma in these children. We look at gene expression in the peripheral blood, white blood cells. The microbiome, we sequence all the bacteria in the stool samples. We determine the genetic sequence of all virus, and we do proteomics analysis, which means we are looking at all the proteins in the plasma. This is the way the laboratories look like. We have contract laboratories in the TEDdy study, lots of machineries, of course. This is early results from sequencing the virus in stool samples of the TEDdy children. Blue columns are children who had developed a first islet autoantibody. Red columns are the match controls. The match controls typically would have the same HLA, born perhaps even in the same hospital, the same month, same sex, right? Same gender. So we could really match them to find out the difference. And all the names at the bottom are the different viruses that we look at. And TEDdy discovered new virus that has not previously been known to humans. By just simply sequencing everything we find in the children's stool sample. This is the overall picture of the microbiome. There are 11 families of different bacteria in our stools. The human's second genome, our stool, is living with us, and we can't be without them. They make things that we need for survival, and they sort themselves into these 11 families. But when we do the analysis, it turns out that there is a cluster of blue bacteria and red bacteria, which means that the composition of these 11 differ between the children. And the major finding so far in sequencing the stool bacteria is that they differ in terms of what they do, these bacteria. So to your left is a lot of blue color, which means rare presence. They're not present in the cases to your left, which are the children with an islet autoantibody. Okay, so you see they differ in what they do. And this is a result of the child developing an islet autoantibody. So this mystery will have to be resolved for us to understand the role, the interaction between perhaps a enterovirus infection, how the enterovirus infection is changing the way the stool is working with us. So the cases become so different from the controls. And we, of course, we are hoping that this is one way for us, the TEDdy Sherlock Holmes, working on the final trigger. This is the way for us to find what the trigger might be. So if you have one islet autoantibody, is the child then going on to diabetes? If the child develops a second autoantibody, is the child moving on to diabetes? If the child develops a third, what happens? And that was the slide that Bill had a black box. These are TEDdy results. I don't know where Bill got his data from, but this is the real thing, Bill. And you see the black line is the TEDdy children with one islet autoantibodies. We don't have TEDdy children developing diabetes with complete absence of islet autoantibodies. You have to have the islet autoantibody. Black is 1, red is 2, and 3 is blue. And it means that in the TEDdy study, about those children who had 3 autoantibodies, they developed diabetes, more than half of them within 3 years or within 5 years. That's the reality. 2 antibodies or 3 antibodies is the same thing as diabetes, but it's without symptoms. The TEDdy study is a virtual study. We can go into the TEDdy website anytime during the day, and look at the numbers. It's updated continuously. These are November 5th numbers. We have 178 children now with 2 or more autoantibodies, which means that we have 178 children who are going to develop diabetes. We can't really say when. And the most fascinating thing is that we ask the parents what they do. So the question to the parents is, do you as a parent to a TEDdy child actively change your way of living and feeding the child because you know that the risk of developing diabetes is increased? So what do you think the answer is? Yes, of course they do. They go on the internet, they read everything about that's been done in the past. We don't eat enough fish, so now TEDdy children eat fish. We don't get enough omega-3 fatty acids, so what do they get? Well, they get Eskimo kids, right? And they don't get enough vitamin D, so now everyone is supplementing their children with vitamin D. And we have a group of 124 parents who put their child on gluten-free diet. And I'll show you soon why. 195 have developed diabetes so far. So the newborn screening, under the age of 5, in the TEDdy study, only 13% developed diabetes with symptoms and symptoms with ketoacidosis. And you can see that in other studies, the frequency in the search study, the US study, is 36%. It's very important to be able to diagnose the disease without symptoms. So TEDdy is not the only diabetes that Bill pointed out. We know, and the reason we are doing this is that we know since way back that about 10% of children newly diagnosed with type 1 diabetes are also going to get celiac disease. So the HLA-DR3 genotype, the illustration in your right lower corner, where GAD is, and the 3 4s, the one with insulin autoantibodies, those are 90%. 90% of children developing celiac disease have these 2 genotypes. So what happens in TEDdy is shown on the next slide. So the celiac disease in TEDdy is bigger than type 1. 325 children have been diagnosed with celiac disease so far. Okay? You can see the number in the circles. TGA is the autoantibody we measure for celiac disease. And you can see we have 506. Type 1 diabetes, when this slide was made, it was only 123. We had to remove 20 because they were too young. But you can see it's only 6 with both diseases. Only 6 with both diseases. So the triggers are different. And we have 325 minus 6 who are now treated for their celiac disease. And how do you treat celiac disease? Gluten-free diet, right? So in the TEDdy study, there is a study in the study with 319 children on gluten-free diet. And how many of them will develop islet autoantibodies or maybe go on to diabetes? Very unexpected, but very elegant. So conclusions are, islet autoantibodies were triggered early in life, earlier than we anticipated. Respiratory infection 3 months prior to the first islet autoantibody is an indication perhaps that there was an infection that eventually led to the triggering of that autoantibody. The bacterial stool composition was affected prior to the islet autoantibody, and probiotics protect before 3 months of age. And also, of course, that we confirm other studies that the number of islet autoantibodies determines the risk for diabetes. And early screening prevents ketoacidosis. And that, we think, is extremely important. So if we, in the back there, click on the link at the bottom, you are actually going to meet Teddy children all over the world for the next 5 minutes.
Hey Teddy kids, you've been participating in Teddy since you were born, so you probably know a lot about Teddy, especially if you've read our junior scientist books. Today we want to show you just how big Teddy really is. Kids just like you participate in Teddy all around the world. There are 6 Teddy sites, with 3 located in the United States, in Washington, Colorado, and the Florida-Georgia area. Europe has 3 sites located in Sweden, Finland, and Germany. Let's go visit Teddy kids at all the Teddy sites. Grab your passport. Our first stop on our world tour is the European country of Sweden. The Sweden Teddy site is made up of clinics from 3 different cities: Helsingborg, Kristianstad, and Malmo. In Malmo, you can see the special building, Turning Torso.
Kära lilla blommiga tappia! Jag heter som sagt fröken...
Sweden is known for Astrid Lindgren's world, where you can meet Pippi Longstocking, Emil i Lönneberga, and more fairy tale characters. In Sweden, they like to swim in the summer and go bike riding. Some Teddy kids even bike to their clinic visits. Teddy kids visit Lund University or Skane University Hospital for their visits. Let's meet some Swedish Teddy kids.
Hej, jag heter Nikita. Hej, jag heter Malin. Vi är miniforskare i Sverige. Hej då! Jag är med Teddy. Sweden!
Our next stop is Finland, also located in Northern Europe. Finland has 3 Teddy locations. Turku is Finland's oldest city, founded in the 1200s. Located by the Baltic Sea with its beautiful islands, makes it a great place for summer camping and boating. Tampere is located in the middle of 1,000 lakes and has a well-known amusement park. Oulu is a unique place where in the middle of the summer the sun never sets and you can see the beautiful northern lights. Hello from Finland!
Hei, mä oon Anni. Tässä on mun pikkuveli Jaapo ja me käydään tenttissä. Hei hei!
Now we're heading south to Germany. The German Teddy site is located in the beautiful city of Munich. Munich is famous for its Oktoberfest, the world's largest fair. Children can enjoy riding roller coasters, eating cotton candy, or playing games. Some of the children like to wear the traditional Bavarian costume, Dirndl for the girls, and Lederhosen for the boys. German Teddy kids visit their Teddy clinic in the heart of Munich or participate by phone and mail throughout the country. Guten Tag from Germany! Now we're heading back across the Atlantic Ocean to a Teddy site located in 3 cities in Georgia and Florida. This area is known for southern hospitality, down-home cooking, and hot, humid weather. Atlanta, Georgia is the home of Stone Mountain. The Masters Golf Tournament is played in Augusta, Georgia. And Gainesville, Florida is famous for the Florida Gators football. Teddy kids in Georgia, Florida have their visits at Georgia Regents University or the University of Florida. A big hey y'all from the South!
Hi, we're from Florida. Go Gators! Hi, I'm a Teddy kid from Georgia. I'm a Teddy kid in Georgia. Georgia, Florida!
Our next stop on our Teddy World Tour will be another site in the United States in the state of Colorado, near Denver. Colorado has over 300 sunny days per year. Kids often go skiing in the winter, and in the summer families enjoy hiking, camping in the beautiful Rocky Mountains, and playing in the outdoors.
I'm teaching you how to roast a hot dog.
Teddy kids visit the Barbara Davis Center for their visits. Let's meet some Teddy, Colorado kids.
Colorado! Teddy kid and I live in Colorado. I'm a Teddy kid in Colorado.
The final stop on our Teddy World Tour is in Seattle, Washington. Seattle is home of the Space Needle and Pike's Place Market. It can get pretty rainy, but also has lots of beautiful sunny days. The main Teddy Clinic is located in Seattle at the Pacific Northwest Diabetes Research Institute, but has satellite locations all over the state of Washington. Welcome to Washington!
I'm a Teddy kid! I'm a Teddy kid!
Thanks for going on the Teddy World Tour today. You and the other kids you met around the world all participate in Teddy to help researchers find the cause of type 1 diabetes. Teddy is such an important study, and we could not do it without you. See you next time!
Two things came to mind during the presentation. The first is just think of where we would be in trying to analyze the data if it wasn't for the founder of the building that we're sitting in. I was just kind of picturing 600,000 fellows going through the data manually, and we probably get the results in about 20 years. It is pretty phenomenal. The second thought I had was a little more mundane, and that is that had I known how much stool was collected, I would have thought twice about shaking hands with Dr. Lernmark earlier today. We're running a little bit late. I think what we're going to try to do, with your permission, is have the talks, and then maybe before lunch, we can spend 15 minutes with a panel with everyone up here and give you a chance to ask questions. So if